So now try to understand. Mm, okay. So we tried to understand what is simple linear regression. Then we try to understand the multivariate and polynomial one by one. Okay. So in the linear regression, we understood that there will be a historical data that will on which we will train the machine learning algorithm, and then we will do some type of testing. On that basis, we'll find the accuracy. Okay, accuracy will find from maybe we'll use one of the criteria like maybe MSC, RMSC, MAP, ME. What are the cons and pros of each and every one? We'll discuss it in uh, later on classes. Okay. And this, for example, a simple linear regression, there will be one input variable and one output variable. The first we will do the relationship between them, how they are related, whether they are related itself or not. Okay, so correlation factor. Okay, then in simple linear regression or in any linear regression, sorry, okay. So what I'm trying to say, in simple linear regression, basically a linear regression model tries to fit a best line among the data points, okay, which has the lowest error. Okay, the error we find from the predicted value minus the actual value. Okay, that is error, and we try to take the square or of error. Okay, square means actual minus predicted ka whole square. Why? Because if you directly take only actual minus predicted, then for the different values there will be sometime it will be plus, sometime it will be minus, and eventually it will reduce the what I can say, it will reduce the efficacy of the total error, right? So to have the error part of each and every data points, we do the square part, right? And we tried to take that line, okay, which has the minimum error, right? And there can be a number of possibilities of having this lines among the data points as we discussed. So only that line will be taken which has the minimum error, right? And how to calculate the error, this is the formula, right? And the minimum error is that error which has the lowest, or it is the minimum point, or I can say for the mathematics, right? It is the minimum point in a error versus weight graph. What is weight? In simple linear regression, the equation for this is equals to mx plus c, where c stands for the intercept, m stands for the slope of the curve, and y is the output, right? So you can divide this equation with the dy by dx, right? Equate it to 0. You'll find the critical points, and then double differentiate the equation, then find the values by putting the value of x1 and x2 and find the value whether we are at the maxima point or minima point. That's how you will find it, right? That's how we do. And so as I told you that we'll train the data and test the data. So we will basically divide the data, the entire data, into two halves. One will be training or train data, and second one will be the test data, right? Usually industry standard wise we do it 70% 30%, right? Or 80% 20% is a standard industry standard. Okay, that's how we go. So if we have enough data, enough means very large data, okay, millions of data is there. Sorry, very enough data. So what we do basically, from the training data, from the trained data itself, we divide this training data into two other categories, maybe the trained data or the validation data. Validation data is a data set from the training itself where it works as a test data, where it works as a test data for the machine learning algorithms. So first what we do, we take the trained data, we basically train the machine learning algorithm on this, then we validate that training data over the validation data set, okay. Then we do some hyper parameter, then we find the accuracy basically. What happened here? Just a second. Then see, validation data, we test on it, then we find the accuracy, then we do the some hyperparameter tuning if possible, then we again do the test and we'll find the increase in the accuracy, right. We'll train the data on this hyperparameter tuning and then do the testing on the validation data set, and we'll find the accuracy, the phase 1. Once this is done, we'll combine the entire training and validation data on this machine learning algorithm, which we found as a hyperparameter tuning. We'll combine both. We'll do the new testing with the test data that we saved for the later on purpose, okay. And we'll find this y cap, predicted values, and the actual values. On the basis of that, we'll find the accuracy. If the accuracy is still very good, okay, we'll directly send it to the deployment phase, right. That's what we try to understand, right. And these were the uh, a thing that I told you about the maxima and minima, right. Similarly, for the multivariate linear regression or multinomial linear regression, there will be more than one variables, right. There will be more than one variable into the data set, uh, which act as an independent variable, and the dependent variable will be y, which is dependent on this multiple independent variables, okay. So the equation will stand for like beta 1 x1, beta 2 x2, where beta 1, beta 2, beta 3 are the slopes, okay. m1, m2, m3, m4, okay. C is the intercept, okay. Now PLR is the polynomial linear regression. Polynomial linear regression means when you have a degree. Right now, in a simple linear regression and multivariate linear regression, the degree was 1, okay. But now we'll have the degree as 2, 3, 4. That is the polynomial when degree is not equal to 1, okay. That's the thing, okay. Any doubt till now? Okay, take care. So now we'll do something like we'll try to basically find the machine learning linear regression. First we'll try to visualize with the Excel first, okay. Then we will try to find the value, okay, with the Python, okay. And before going, I want to tell you some of the accuracy factors, what are the involvement into it, okay. So before going, try to understand on, for example, we have, just a second, So let us take an example like there's a data set. There is a data set, okay, which is having, let's take an example with a simple linear regression, that is x is a independent variable and y the dependent variable, okay, x1 x2 x3 x4 and so on, y1 y2 so on. This is the data set on which we want to train a machine learning algorithm so that whenever new data point comes into the machine learning, it predicts the output with the highest accuracy, okay, ठीक है. So generally what I can tell you, generally if you don't have machine learning algorithm, okay, just uh, don't think that we have machine learning algorithm, okay, we're general, we're general people, or we're in general life, okay. What you will do if someone, like for example, take it like that, okay, you went into the market to buy tomatoes, okay, but how much money you should take, okay, from your home, right, to buy that tomato? That is a question. Why? uh, Someone came to you and they told you that tomatoes, like for example, he told you about 7 days tomato rate, right? Like some day it was 20, next day it was 21, the next day it was 18, then the next day it was 19, then again it was 22, then it was 20, it was 21, it was 20, 18, something like that. He told you the variations into the price of tomato, right? So now what you will do? Any idea? Today you're going for the uh, going to buy the tomato. So there is two way, okay. One is like very general thing, like you'll take the as much as money you can, and you can buy and go to the market so that whatever the price of the tomato is, you can buy it. So that's very general purpose. There's nothing mathematics involved into that one. So what you will do, like as a method, you'll take the average. Like on an average, the rate was like this one, like 20 rupees, for example. So you will take around 20 or something extra money. You will keep it, right? And you'll go to the market, right? So average is one thing, right? So generally in normal life, when there's a variations, na, we take general, right? General means average, right? Average of each and everything. Okay. So generally that is also prediction, okay. So let me tell you, for example, y average is the average of all y, कह सकते हैं, right? So let me tell you, let me draw a graph for you all, okay. This is also a prediction, right? This is also a way of predicting, right? It's a general way of prediction, but it is also a prediction, average. So now let me Does Ganga joined? No. Pro- Prabalika? Prabalika? Where is she's gone here? Where is Ganga? I don't know, sir. Right? Okay. She messaged me yesterday. She's going to her native place. I don't know whether she has gone or not. So, okay, this is the date. So now our best. Okay. Uh, linear. What? Anyone trying to say something? No? Shall I continue? Okay. So the Ganga is what problem? Pravalika. Little network problem. Okay. Where you are living here? I don't know. Matlab, you are facing so much of network problem in the world of 5G. It's totally. Well, I don't understand. Okay. So this is the data. Okay. This is for the every x. Okay. For every x. Okay. We had definite y. Right. From this data source. Now, the with simple linear regression, the best fitted line will be that line which have the minimum error, right? So let me put a line. Okay, let me put a line. For example, I'm just taking this line as our best fitted line. For example, okay, fine. Now let me remove this one. I don't want the same color to be here. Just focus on it, right? A very essential concept. I'll try to be as lucid as possible. And let's say this is, can anyone tell me, this is y average line, average. Okay, this is also a prediction, this is also a prediction, right? This is one. Now if I'll take a slope, if I take a slope of this one, if I take a slope of this one, so what do you think? The slope should be very high or slope should be less compared to this one? This is also slope, na? Slope with the y average, yes or no? And also this y average line is a single line. Like for example, why single line? For each and every value, just try to understand. For each and every value, our prediction is y average. On any day, I have this y average only. Yes or no? I'll prove it with the Excel itself. Don't worry. But are you getting my point? Y cap, right? So for every value we have y average. For every value we have y average. For every value we have y. So this y average is a constant for each and every x. Yes or no? So this will be a straight line parallel to the x-axis. Okay. Let me tell you one different story. In some batch, I received a guy. Okay. He was a commerce graduate. He never learned maths after 10th. Okay. In 11th and 12th, he was a commerce student. He did bachelor's in commerce and right now working in somewhere, okay, into the same type of thing. So what you find is that guy is a good candidate for data science. What do you think? Why? Yes, I was like, oh my god, a problem kya hai? What is the like? If code till code, okay, but if I'll come into mathematics side, like this type of numerical analysis we will be doing. So from the scratch, I need to tell what is integration, what is differentiation, because if you have not learned anything into the graduation itself, you might have seen or heard something into the 11th and 12th. So you at least know what is integration, what is differentiation, what is maxima, what is minima, what is this matrix multiplication, eigenvalue, eigenvector, and lot of other concepts that we're going to use into this one, slope, intercept, and these are the starting one, probabilities, distribution, right? And going forward we'll do more mathematics type of things, right? So I was like, oh my god, if he's totally into commerce, how will I teach? Because I was like, he will not understand anything, damn sure. However, I do hard work behind him, okay, he will not going to get understand. Agree? So after some time he itself left because of mathematics. Then I thought, that's very good. Internally, why? Because I can't tell anyone, I can't demotivate. If someone is trying to do something, I can't demotivate, right? You don't do this, it is not, you're incapable. But I told to him that you need to do a lot of hard work in the mathematics side, right? So somehow he left, like, okay, fine, good. Okay, now come to this one. Okay, mute yourself, everyone. Now see, my voice is clear, no? Is any background noise is not there, right? Okay, fine. So see, this is slope. So what do you think? The slope should be higher, slope should be less. If the slope will be less, so what do you think? This curve will match this one, or it will go above? If the slope is low, this will come this side, right? It will come. If it will close to average, then what is the purpose of creating a linear regression? Any algorithm? Getting my point? There is no use, na? There is no use. If you want slope lesser, so let's take a slope. Like for example, this is slope theta. This is slope theta. If lesser, the ideal should be 0. The ideal should be 0. If you want a slope should be 0, then what it mean? You want the y average itself. It should collide with the y average line. Then what is the purpose of creating a linear regression or any algorithm? Use the y average, na? Take the mean of everyone, y1, y2, y3, y4 upon total number. You have this one, right? Huh? So our main aim should be, it should be greater, the linear regression line, okay? But when not, we'll see. That is a one concept, right? Okay, very good. Now we'll move ahead. So I'll make one more graph, not like this way, in a very shorter graph to make you just understand the concepts. Okay, just try to understand. Just try to understand two concepts. Write down in your book sum of square of total, sum of square of residual, and sum of square of error. Just write it down. Once done, let me know. Sum of square of total SST, sum of square of error SSE, sum of square of residual SSR. Done. Very good. Very good. Very good. Done, everyone? Right? Very good. Now try to understand. Let me draw one more graph to you all so that you can understand. So I'm drawing one more additional graph over here. Okay. Done. Okay. I'll not draw a lot of things in this graph. We'll take some of the important factors only to make you understand. Okay. Take it. Now let's make, like for example, this is your y. Y means this y. Okay, actual y. This is actual y. Then this line will have the predicted part, right? Let's have here, this is y cap predicted, right? On the linear regression, the predicted part that linear regression had, right? Algorithm. And this is your average, right? This is your y average line, right? This is y average, and this is your x, right? This is a line of x, right? X axis, and this is a line of, very good enough, y axis. Okay. Now for this particular x, this was the actual value, right? This was the actual value, but our machine learning algorithm, linear regression in this case, is predicted this y cap, right? But by average, this was the r1, right? So the error, okay, just try to understand the error part between this to this is known as SSE, that is sum of square of error, okay, between the actual value and the predicted value by the machine learning algorithm, okay, SSE. Now the difference between the machine learning algorithm predicted value and the y average is known as sum of square of residuals. Sum of square of residuals. Okay. And from the actual till the average, this is known as sum of square of total. Right? So, in very short, I can say sum of square of total is equals to sum of square of error, where sum of square of right here. Because as I told you here, this line should not match this one. The slope is very low, it will directly collide to the y average. Then there is no purpose of any having any machine learning algorithm, right? There is no purpose, or any that linear regression model is very bad, I can say, if it is colliding with the y average, right? Try to understand, right? So it isn't good thing. Okay, that's why the maximum error should be from the y actual with the y average, because if we are planning to have a machine learning algorithm, then the error should be less than the y what the y average is giving us, right? It should be less, na? Getting my point or not? Right? That's why whatever the error was with the y average, so it will be very high with compared to the linear regression, because we have made any linear regression model to decrease the error part, right? That's why sum of square of the total is equal to sum of square of the error. Maybe we try to decrease the error part, right? But we can't even decrease the entire one, right? Getting my point? We can't decrease the entire value. What this y cap should be collide with the y, then only it will be like what I can say, will be 0, right? Right. Huh? But since y, this linear regression is a straight line, so somewhere it will collide with the this type of y. Somewhere it will collide, y cap and y both will collide, but somewhere, since it's a straight line, there will be a difference of the error, right? It is not like a curve ki it will fit with everything. It's a straight line. It's a straight line. So whatever the y is falling onto the straight line, there the error will be 0. But whatever the value that are not falling onto the straight line, there will have some error. There we will have some error, right? So eventually, if we'll find out the overall error will be something there for the linear regression itself, right? We can't decrease the entire one, right? We have tried. So with comparison to y average, this line, we have decreased a lot of errors, but not complete, right? That's why even after the what I can say linear regression, there is still some of the error part left, right? Getting my point? Right? This was the error, or basically I can say this is the error that we saved with the SSR. Getting my point? This was the entire error, and with this linear regression we saved this error, right? Now with this predicted y, we have only this much error with the linear regression. Getting my point? We don't have this error, right? That's why. Okay, so if we want to write it like this way, like we can write for summation, try to understand y minus y cap, right? Whole square, plus we can write summation y, right? That is y cap minus y ka average, right? Whole square. Are you getting my point, everyone? Very good. So int and this sum of square of total will be summation of this y minus y average, y minus y average का whole square. Yes. So these are sum of square of error and sum of square of residual, and we also cited measure of uh, unexplained variation. Measure of unexplained variation. ठीक है? And this is known as measure of explained variation, right? Measure of explained variation. Why it is known as measure of unexplained and explained? Can anyone can tell me? If you if you have got any intuition. Anyone? No. Okay, see. This is some square of error, right? Unexplained, and this is explainable. See, this sum of square of error, whatever we have got, it is explainable. Why? Because this was a total error before, right? When we didn't have any linear regression model. So once we had this linear regression model, we saved this sum of square of error, right? We saved, and now instead of predicting y average as the predicted value for this x, we are now predicting y cap as the predicted value for this particular x, right? So this y cap is now explainable, right? Now still after creating this line, still we are not able to decrease entire error, right? Only those error we try to get as 0 where the numbers are falling onto this line, but if the number is falling above or below this line, there was some error still left, and we can't basically fit on each and every data points because it's a straight line, it's not a curve, right? It's not a curve, it's a straight line. That's why we are not able to completely reduce the error, right? That's why it is known as unexplained variation, right? Look, theoretically we are able to explain it, right? We are able to explain, but look, practically we are able to explain it, but theoretically we say it like that way. Able to understand? Able to understand? Okay. Now let's see. We'll use this sum of square of errors and sum of square of residual and sum of square of total to find the sum evaluation metric. And what is evaluation matrix? Let me tell you. Just try to learn or do the by heart r square. This is known as r square. It is also known as coefficient of determination. Coefficient of determination. Okay. The formula for the r square stands for SSR, that is sum of square of residual, by SST, that is sum of square of total. Okay, so if we want, we can even try to break it like sum of square of residual by sum of square of error plus sum of square of residual, right? And the value of r square belongs from 0 to 1. Okay, and I'll tell you what are the significance, why we are basically, what is the meaning of r square. I'll tell you, not only for that one. Okay, ah, what is r square means, right? So, okay, so basically this r square represents r square represents the percentage variation in the output. Write it down. The percentage variation, in output. Okay, that is the output is under dependent variable, right? Dependent variable. Okay, explained by the input variable. Explained by input variable. Okay, or we can also write it like that, or percentage of response, or percentage of response. Okay, variable variation, variable variation that is explained by its relationship, that is explained by its relationship with one or more predictor variables, with one or more predictor variables. Okay, the most important, I'll tell you that. So, are you able to understand? The r square represents the percentage variation in the output explained by the input variables. Okay, or the percentage of response variable variation that explains relationship with one or more predictor variable. Means what? If you have a data set like x1, x2, x3, right? And for example, let's take 3 1. Okay, and this is output. So this output is always dependent variable on these variables, right? So if you find the r square, okay, and if you get any value, then this value is saying as a percentage, like you'll get the value between 0 and 1. Okay, 0 and 1. For example, 50% you got, that means 0.5 or 0.3 or 0.8, something like that. So whatever value you got, so it means these variables are able to explain the value of y. For example, you got 0.8. It's a very good number, but still, let's take an example, 0.8. Okay, that means these variables are able to explain 0.8, yani 80% of the variations in the y. What is variation? Variation means the y ka value will be like y1, y2, y3, y4, y5, y6, right? If you take out the average of this one, that is y average, and it will be a single line, and these all values are up and down. Yes or no? So this is the variations. Remember the variance. Remember, right? So this all y, different y ka value, somewhere 20, 30, 80, 20, 40, 30, 20, 80, anything. Okay. So whatever this x ka values are there, okay, whatever this x ka values are there, this independent variable is able to explain the variation into the y 80%. Getting my point? Is able to explain 80%. Okay. So tell me, the value of r square should be high or should be low? Reason? Then lesser this x is able to explain the variation, right? So what do you want? The variation should be less correlated with the independent one, or highly correlated? Means what? If you are basically providing a relationship between these x values and the y, right? You're basically finding the pattern. So what do you think? Whatever the value of x you are giving for the training part, this should have a relationship with this y or not? It should have. Means if it has the relationship, then it is able to explain the y ka value. If we are providing this one, then it is able to explain this y ka value, yes or no? Then it is, and the similarly this value will be also able to explain this value, right? For example, and so on, right? So what do you think? It should have the independent variable should explain the variation into the y, or shouldn't? It should, no? It should. Then only you can find the pattern, no? For example, sometime the value of x1, x2, x3 will be different, so the y ka value will be also different. Sometime x2, x1, x3 again will be different, then the y will, that's why you have the variations. If you don't have variation, means for each and for each and every different value of x1, x2 and x3, you have same y. Getting my point? Then only you will don't have any variation, right? Getting my point or not? Are you able to understand? No. It means that the independent variables are able to explain the variation into the y. Getting my point? If you don't have y ka variation, means for every input of x, you have same y, right? Y average. That is not the case. For every different input, there will be different y, there will be different x, different y, different x, different y, right, Anufa? So the right model should be that that for each and every x and for every y, it should explain the variation. Yes or no? Getting my point? It should explain the variation. So the r square should be high, na? Hmm? So if r square is between 0.6 to 0.8, then we say it is moderately um, correlated or moderately able to explain the uh, variations. Okay, it's not the correlation coefficient. If I'm writing correlated means it's not correlation coefficient. That's totally different. It's r square. If r square is greater than, I can say 0.8, then we say it is strongly correlated. Getting my point? Strongly correlated means it is strongly able to explain the variations of y with independent variables. Able to understand? Very good, very good, very good. Now let's do one thing. Let's create a what I can say. Now there will be an adjusted r square also. I'll tell you what is adjusted r square. Just you write a topic as adjusted r square. For that I'll tell you what is adjusted r square also. Okay, what we mean by adjusted r square. Getting my point? What is adjusted r square? Okay, so before going to the adjusted r square, okay, so now we have r, we learned about the r square, and we'll do some of the what I can say use case with the excel, and I'll try to show you. Okay, but write the topic known as adjusted r square. Okay, now let me open excel so that I can show you. Just a second, give me 1 second time. Now, so before going into that, let me also give you one more equation, one more thing, that is like, for example, y is equals to mx plus c for a simple linear regression, right? Remember? Then if I want to ask what is the value of this c, then what you will do? Basically for c you will do y minus of mx, right? Very good. And for the slope, what you will do? We'll take the x, what? Y minus c by x. Okay, but that is different for different values. Like for example, x second, one call is coming, just a second. हेलो.
हेलो भैया.
हाँ बोलिए.
आ गया हूँ.
आ जाइए आ जाइए.
हाय सिंपल.
हाँ हाँ आ जाइए.
ठीक है, आ रहा हूँ.
Okay, so see why I wrote mx bar over here, because this y will be like this one, na? For y, for x1 value, this will be the y1 value. For x2 value, this will be y2 value. Remember? For x3 value, this will be y3. Getting my point? So different x, there will be different y. Getting my point? Similarly, this c will be also there. So c will be the constant. C is always constant. Remember? So that one will take y minus mx ka bar, and for the slope we'll do the summation. Just try to understand how we are doing. Okay, we'll do xi. I stands for the different I. x minus of x bar, okay, into y का I minus y का bar means y का average, okay, upon summation of x का I minus x का bar, okay, का whole square. So this is the formula, okay, this is the formula for y for simple linear when you have only one x. Getting my point? Now just write down this formula. Just write down this formula. We'll see this thing practically and then we'll move into the codes. Okay? Getting my point, everyone? Okay. So now we'll see this one with the Excel. Let me open the Excel. Okay, now Excel is there. So let me do one simple thing like years of YOE stands for year of experience, and this is salary, right? Salary. And let me give it some arbitrary value like 2 years, 3 years, 5 years, 13 years, let's for example. Then we'll take 8 years, then we'll take 16 years, then we'll take 11 years, then let's take 1 year, then let's take 9 years. Okay? Salary. Give the arbitrary value 15, 20, 42, then let's take 64, then stick 50, then stick again 90, then take 58, then let's take 8, and then let's take 54, right? ठीक है? So let's do some of the okay. Let's do some of the what every girls want, some makeover to this value. Let's do this. Okay, I don't think you are able to see able to see, no? Okay, so now let's find the y average, for example. Okay, let's find the y average. Okay, y average. So y average will be the average of entire y, yes or no? So it came out of 45.8, 45.8, not 45.4. Okay, now we'll find the error. Right? So what should be error? Error will be this one, right, minus this one, right? Function f, right? Okay, so we got around minus 30.4 का error. Getting my point, everyone? So this is error with the y average, again we'll do this one and we'll do this one. ठीक है? Now what we'll do the control C, control V, will do the error का square. Remember, we'll do the error का square, right? So what we'll do this one, okay, and we'll do the error का square means we'll do the same thing, like for example, right? हो गया ये भी, right? I'll just drag it down and we'll take it till 2 on. Let's take it like this one, right? And we'll do the summation for the error square. Getting my point, everyone? This is the way we do, right? Right or not? Right? Oh. So we'll do the average of it. So not average, we'll do the sum of it, right? We'll do the sum of it, sum of the errors. So this is our total sum, yes or no? Yes? Okay. This is the basically error that we got. With whom? With the average line. Right? Okay. Now let's do one more. Control C. Let's put it. Let's sit over there. Let's put it here. Control V. Okay. So this is basically for the uh, prediction on Y average. We did prediction on the Y average. Yes or no? Tell me. Huh? Let's do this. Sorry. This is prediction on the Y average. Now we'll do a prediction on linear regression, right? Let's do it this. But I'll do that one after. So we know we have a equation. We have a equation. What is that equation? Tell me, anyone. Equation is y is equals to mx plus c, right? On this way we'll do the predictions. We'll do the prediction. So first we will find the y ka cap. First we'll, right? We'll find the y cap, and the y cap will be with this one. Oh, sorry. Control set. This one. Okay. Y cap. So tell me the y cap. Find the value of m. You have the formula. You have the formula. Yes or no? So before okay, just do one thing. Before finding that one, let's do let's find the xi minus x bar. Remember? Huh? What was the formula? Tell me. So the formula was, try to understand, the xi minus x bar, yi minus y bar upon xi minus x bar ka whole square. So let's find all these three values. Let's find all these three values. Yes or no? And also I just forgot one thing, that this is y bar. This just a second. Yep. This is y bar. Y bar minus mx ka bar. Okay. The average of y and the average of x will give the intercept. Okay. Okay. So before finding this y cap, let's find all those values. Okay. And let's find it. First we'll do this one. Instead of writing that one, let's write it like we are about to find like x I minus x bar. ठीक है, एक्स आई माइनस एक्स बार. ठीक है, then we'll find yi minus y का बार, yi minus y bar. Okay, then we will find what? Tell me. The multiplication of both. Remember, the multiplication of this one and just let's take it, control C, and let's put it here. and let's this one, and let's put it here, right? This will be this one, remember, formula wise, right? And this will be the xi minus x bar ka whole square. Let's put it here, ka whole square, right? Now let's make it into the table. Done. So let's find the x bar first of all, right? X bar is the average one, right? Let's find the average formula. Let's use it. Done. Done. Let's find the y bar. Let's put it into the some less value. Let's put it like average. Okay. What? Let's again do it like this way. Able to getting my point, everyone? Yes. It is 45 or minus 45. What am I? Okay, there is minus over there. Okay. Take care, because I thought there is 45. Why it is coming minus 45 over here? Okay. Now what we'll do? We will basically xi. This is x, and we'll minus with the x bar. Remember? And we'll make it fixed. Okay, just we'll make it control F4, makes it fixed. Okay, now it's done. We'll drag it down and we'll have all the values, and we'll do it like this way. And then we'll do for the x bar से किया. Then for the y bar is this one, and we'll minus with the this one, and we'll make it fix. Done. Okay, then we have y minus y bar, right? Done. We'll float it. Now we will multiply both, right? This into this. Done. We have another values. We'll drag it down, and we'll do this one. Make it like this way. Okay, sorry. So we left the last one. So we'll drag it and we'll have it. Then we have to square this one, right? So what we'll do? We can do this again into this. Then we have this value. Drag it till here, and we'll have again one value. Done. Now do we have everything with us? Now do we have everything with us? Now we know the summation. We need to the summation of xi minus x bar, this one, right? What is the formula? Tell me. What is the formula? Tell me. Y bar. Yes. Right. So this is xi minus x bar into y minus y bar ka form values. So we'll do the sum of each and everything. Then we have the value, right? And then we want this one, right? So we'll do the sum of all these values, right? So now what is the final one? Now we will do the m ka value. We'll find the m ka value, right? So m ka value will be this divided by this. Remember? So this is our m. This is our m. Now find the value of c. C का क्या है? Y average minus m into x का bar, right? C. The C will be y average. This is y average minus, let's put it m into x bar. Sorry. So we'll do the m into x ka bar, right? right? So we got the value of x. Yes or no? So now we have everything. We have everything. M भी है, x भी है, right? And c भी है. Now we'll use this formula. Yes or no? This will be y cap. Yes or no? So let me let it like y cap. Okay, this is y cap, and let me put it like this way. Oh. Mm -mm. Mm -mm. ठीक है. Okay. So now we'll have the formula like mx plus c means this is m x, sorry, x into, it will be like, let it put into the bracket. Okay, just a second, let me put it into the bracket. M into x, right? Where is x? This is x, right? mx plus c, this is plus c, right? So let me put m as fixed and c also fixed, right? And let it vary the x. So now we have this much value. Drag it down. So are we having y cap, right, for each and every value? Y cap. So now we'll find the error, and error ka square the same way we did earlier, right? So let's use this two thing, error control C and control V, right? And let's go down and let's use this one. Okay, so the error is, this is y and this is y. Done. Drag it down. Sorry. Okay, done. Then the square of this into same number, we have this one, right? Drag it down. Let's make it this one. Okay, then let's the sum of the error, right? Let's use the sum of errors. Oh, formula went wrong. Sum of the errors, right? We'll use sum of the errors. Now tell me the error. What was the error before and what was the error now? What is the error now? So did we decreased the error or we increased the error, or the error is same? The error that we decreased is sum of square of error or sum of square of residual? Try to see. See, this we decreased, right? Earlier we were here, now we are here, so we decrease sum of square of residual, that is known as explained variation. Getting my point? And still we have some error, still we have some error. You can see, na? We tried to decrease the error. We tried to decrease the error. Getting my point, everyone, or not? We tried to decrease the error, but still some of the error is there. That's why we said it unexplained variation or unexplained error. Getting my point? Are you able to understand now? Yes. So now there is one more plot that we can also take it like as a regression plot. Let me use it like this one. I don't know the much more to the Excel, but let's see as I'm able to get any. So for example, this is the plot of this one, right? And we want to put a regression line into this one. Getting my point? We want to put a regression line. What is how to get the regression line in between here? Mm. So now, do you see this one? Oh, just sorry. Okay, you see this one, right? Now I want to plot one more thing. Just a second. I want to add one more. Yes, that we can do now. Select data. Salary is there, right? Okay. Now let's add one more access level. Let's see what happens. It's better. Okay. I can draw one more thing, but I don't want to draw something else over here. Means I can choose this one. I can choose this one. Just I can choose this one as well as this one. Command this one, and then I can go into the insert. Where is insert? Insert, and then we can do this one. Let's see this curve, this curve. Let me put it like a line. Just try to understand it is a line. If I even over map na, you can understand. I just wanted to have a single line in between. Getting my point? Now see, these are the single line. Getting my point or not? This is coming into a single line, right? And this is the actual y, which is up and down both. So this is y mx plus c. This is what mx plus c. So wherever there is some y above or below than this mx plus c line, there will be an error. There will be an error, right? And that we can't reduce with linear regression. There are other machine learning algorithm by which we can do, but not with this linear regression. Getting my point? Okay. So did you understand everything? Very good. Let me put it down this side. Okay. So let me now stop